All right. We're going to finish up this bond pricing worksheet. We're going to answer problems 15, 16, and 17. These are duration problems. Now, in order to understand the concept of duration, I've created another video called The Concept of Duration. So if you need some intuitive understanding about duration before we answer these problems, I would encourage you to go and watch that video. It's a short video, 3 or 4 minutes. It basically explains what duration is. Now, in the previous video, in problem 14, we made the assumption that over a year's period, we bought a bond last year, and over a year's period, the interest rates have increased. Okay? We've talked about in class, and we've talked about before, that the interest rates or the yield to maturity, the bond yield, and the bond price is inversely related. If R goes up, bond prices have to go down. Okay? Now, duration, without repeating myself in that other video, duration basically measures the magnitude of that inverse relationship, and it's calculated in the following way. I'm going to take the present value. So if you just look at the ratio of the cash flows in time period t divided by 1 plus r raised to the power of t, that's the present value of each cash flow. I'm going to multiply it by the time to maturity, by t, and then I'm going to sum up the product of the present value of those cash flows and the time to maturity. I'm then going to divide this by the bond price, and that's going to give me duration. It's going to give me a measure of magnitude of the inverse relationship between bond prices and bond yields. Okay, so that's where we're heading. You should also note, to answer the last problem, question 17, modified duration takes the duration measure that we just calculated and divides it by 1 plus r, 1 plus the yield to maturity. Okay, we're going to do these duration problems in 3 steps. First, we're going to solve for the bond price, which we know how to do. We've been doing that in the previous videos and in class for the last couple weeks. We're then going to solve for the numerator in the duration formula, which is a little more computationally intensive, and then we're going to divide the numerator by the denominator to get duration. Okay, so that's where we're going. Let's pull up the problems here. I'm going to answer all of these problems in Excel. Okay, recall the first step is to find the bond price. Second step is to find the numerator. And the third step is to divide the numerator by the denominator, or the numerator by the bond price. Okay, let's answer number 15. What is the duration of a zero coupon bond, $1,000 face value bond, matures in 3 years and has a yield to maturity of 5%? Okay, so I'm going to go ahead and solve for the price of the bond, the present value. The yield to maturity is going to be 5%, 0.05. Number of periods is 3 years. The payment is a zero coupon bond, so zero payment. Face value is negative 1,000. Again, it's an outflow from the firm's perspective. I'm going to assume compounding at the end of the period. I get a bond price of $863.84. Okay. So far so good. So I've already done the first step. I've calculated the denominator of that hairy formula that we're working on. To get the numerator, I've got 3 time periods, and I'm going to put the cash flows. So these are years, and I'm going to put the cash flows in column C here. I have 0 cash flow in year 1 because it's a zero coupon bond, 0 cash flow in year 2 because it's a zero coupon bond, and $1,000 in year 3. Okay. So now I'm going to have to give myself a little bit more of Excel here. Hopefully you can still read that, read the problem there. Now I'm going to get my discount factor, because I got to find the present value of each of these coupons. Right? So I'm going to take the present value of each of the cash flows, and I'm going to multiply it by the time to maturity, and then I'm going to sum up the product of the present value of the cash flows and the time to maturity. So let's do this. It's going to be equal to 1.05. That's the yield to maturity, 1 plus r raised to the power of 1. I'm going to drag that down. This cell is going to be 1.05 raised to the power of 2. This cell is going to be 1.05 raised to the power of 3. Okay. Now I'm going to get the present value of these cash flows by dividing the cash flow in year 1 by the discount factor I just calculated. Of course, that's 0. Hopefully you can do that in your head. Okay. Now I want you to notice something here. That number looks very familiar, doesn't it? The bond price is just equal to the present value of its future cash flows. So you could probably already calculate the duration in your head. However, what I'm going to do here is I'm going to get the present value of the cash flows times t. This is going to be equal to 0 times 1. If I scroll down here, this is going to be 0 times 2, and this is going to be the present value of the cash flow in year 3 times 3. Cell B8 is 3. Okay. I'm going to sum these up, and I get 2591.51. I'm ready to move on to the third step. I'm going to divide the numerator by the denominator, and I should get 3. That should just be a number there. Give me a second. Sorry about that. Let me just put that in a number. Okay. I get 3. Now notice, if I take the present value of the cash flow in year 3, I sum up these guys. This is the present value of the third year's cash flow in today's dollars, and I times that by 3, and I divide that by the present value of the cash flows in today's dollars. I'm just going to get 3. So this is important. What we've learned here is that the duration of a zero coupon bond is simply equal to the time to maturity. Okay? The duration of a zero coupon bond is simply equal to the time to maturity. In fact, duration cannot be greater than the time to maturity. Now what this means is for every 1% increase in yields, this bond will decrease by 3%. Okay? So hopefully you understand that interpretation. If you don't, go back and review the video Concept of Duration. That will help you. All right, let's answer problem 16 and 17. Okay. Problem 16. What is the duration of a $1,000 coupon bond that matures in 3 years, has a yield to maturity of 9.1% and an annual coupon rate of 6.8? Okay. We're going to first solve for the bond price. It's the present value of 0.091 is the rate divided by the number of periods, 3. The payment is negative 68. Future value is negative 1,000, compounding at the end of the period. And I get a bond price of $941.88. I got 3 years of cash flows. This is my discount factor. Okay. My cash flows look something like this. In year 1, I have a cash flow of $68. In year 2, $68, and in year 3, $1,068. This should be my discount factor. And this is going to be my present value of cash flows. Okay, my discount factor is equal to 1.091 raised to the power of 1. That's 1 plus the yield to maturity raised to the power of 1. Okay, I'm going to take my present values. Right. This is the present value of each of the coupons and the face value here. If I added this column up here, I would get the same bond price that I've already calculated. But what I got to do here is I got to multiply the present value of those cash flows by 1 in time period 1, by 2 in time period 2, and by 3 in time period 3. I'm going to sum those up. Okay, I get 2643.87. The third step is to divide. I get duration by dividing this number by the bond price. And duration is slightly less than 3. It's 2.807. Okay, this is my duration. And this suggests that for every 1% increase in yields, this particular bond will decrease by 2.807%. Now, in previous videos, we've talked about how modified duration modifies that interpretation. To get modified duration, I'm going to take duration. I'm answering problem 17 right now. Take duration. I'm going to divide it by 1 plus the yield to maturity. And I get a modified duration of 2.5729-ish. Okay, so modified duration actually gives us a better interpretation than duration. I'm not going to get into details about this. You'll have to take additional finance classes to figure out why. But modified duration, it gives us a more accurate representation of what's going to happen to this bond price if interest rates change. For instance, duration told us that if interest rates increase by 1%, this particular bond price will go down 2.807%, when a more accurate reflection of what's going to happen is it's going to go down by 2.57%. Okay, hopefully this makes sense. We finished this worksheet. If you have questions, you can email me or let me know. Thanks.